Okay, what we're going to do is go through some of the practice problems from your notes packet on Unit 5, Lesson 2. So if you have the notes from either the Canvas site or your notes packet, you can follow along or just double check your work when you're finished. So I am trying a new program here, so this might take some getting used to. I'm going to get myself a pen and make sure that the color is black. Okay. The first problem says calculate the number of iron atoms in 4.48 moles of iron. So as you know, with dimensional analysis, we're always going to start with the number and the unit. We'll draw our times sign and then our fraction sign. Since we have moles of iron in the numerator, we want to make sure that goes in the denominator because we want it to cancel, and the thing that we're converting to is atoms of iron. So 1 mole contains 6.02 times 10 to the 23rd atoms. That's supposed to be a times sign. So when we do the math here, we're going to take 4.48 times 6.02 times 10 to the 23rd, and we're going to get 2.7 times 10 to the 24th, and the unit left over is atoms of iron. And that should make sense because each mole contains 6.02 times 10 to the 23rd, and we have almost 4.5 moles, so we're expecting a fairly large number. Let's move on to the next one. We're going to calculate how many moles of apples there are in that many apples. So again, let's start with the number 4.3 times 10 to the 24th apples. And the point of this problem is that a mole is simply that number, 6.02 times 10 to the 23rd. So in chemistry, we're usually talking about moles of iron, copper, elements or compounds, but you can have moles of anything. A mole of apples, for example. So if we have this many apples and we want to convert that to moles, we're going to have 6.02 times 10 to the 23rd apples per mole of apples. So when we do the math there, 4.3 times 10 to the 24th divided by 6.02 times 10 to the 23rd, we get 7.14 moles. Remember, the idea of the mole is the same idea as a dozen. If you had 36 eggs, you have 3 dozen eggs. If you have that many apples, you have 7.14 moles of apples. So let's move on. We have 3.4 moles of apples, and now we want to convert that to just apples. So again, we want to put moles in the denominator and 6.02 times 10 to the 23rd apples in the numerator. So let's do the math. 3.4 times 6.02 times 10 to the 23rd, and we should get 2.05 times 10 to the 24th apples. Okay, let's move on. I'm going to start going through these with less explanation and just do the math so we can get through a bunch of these. Okay, so we're going to start with 3.5 times 10 to the 22nd molecules of CO2. And we're saying molecules because CO2 is more than one element bonded together, so it's a molecule. And we're going to want molecules in the denominator, and we're converting to moles. So 1 mole of CO2 is 6.02 times 10 to the 23rd. Let's do the math. And again, just make sure that you can do the math, scientific notation, in your calculator. So we get, hold on. So we get Still trying to get used to this new system. 0.058 moles of CO2. Alright, let's move on to the next one. We have 2.1 moles of CO2. And we're going to calculate molecules. So again, 1 mole of CO2, 6.02 times 10 to the 23rd molecules. Moles cancels, so when we do the math, we'll have molecules left. So 2.1 times 6.02 times 10 to the 23rd gives us 1.26 times 10 to the 24th molecules. Okay, let's move on. We'll just rip through a bunch of these. 1,450 apples equals how many moles? So again, if we have our unit of whatever it is we're looking for, apples, we're going to have Avogadro's number, or 6.02 times 10 to the 23rd of those things in 1 mole of those things, and the thing here happens to be apples. So 1450 divided by 6.02 times 10 to the 23rd is 2.4. Now, are you expecting a large number or a small number? We're dividing 1400 by a huge number, so we're going to expect a very small number. Let's move on to the next one. 4.5 times 10 to the 24th pennies. So again, the number of things, 6.02 times 10 to the 23rd pennies for every 1 mole of pennies. And again, we'll probably expect 4 times 10. Now that's a number's larger than 6.02 times 10 to the 23rd, so we get 7.5 moles. So we have 3.4 moles of carbon atoms. Notice it's an atom, so it's 1. 1 mole of carbon atoms is 6.02 times 10 to the 23rd carbon atoms. 3.4 times 6.02 times 10 to the 23rd, and we should get 2.05 times 10 to the 26th. So you kind of get the idea here. Whenever we're starting with moles, we have 1 mole of something is 6.02 times 10 to the 23rd of that something. So we have moles, molecules. If you go on to the so we already did that one. So now what we can do is we can start doing some dimensional analysis with this. And I think what I'll do is make another vodcast for the rest of these, so this one saves a little bit of time. So look for the next vodcast to go through the rest of these problems.